So today we are going to speak about separation of an unknown mixture of two compounds by acid-base reaction. That's what we are going to do today. And what we need the unknown mixture, which is here. So
it's an unknown mixture.
That's the unknown mixture.
It's two things or
yeah.
two chemicals.
That can be two compounds. That can be acid and a phenol.
Yeah.
That can be an acid and a neutral, or a phenol and a neutral, something like that.
Okay, so phenol, like a benzene with an OH.
Yeah.
Or an acid or a neutral. So but it's two chemicals.
Two compounds.
Okay,
yeah.
It's an unknown white solid. Okay, cool. Right.
Yeah. So, as you see, you need ethyl acetate.
We need
a solvent.
Ethyl acetate. Yep.
Ethyl acetate, that was solvent to dissolve the unknown mixture.
Okay, it's an ester solvent. Yeah. It's just a nice organic solvent. Yeah.
We are going to need 6 molar hydrochloric acid.
6 normal or molar. 6 m.
No, molar.
Yeah,
molar, that's the same thing. Yeah.
So it's aqueous hydrochloric acid. Yeah.
Yeah. We are going to need 5% sodium hydroxide.
So it's 5% sodium hydroxide as a base. Okay.
Yeah.
Yep.
Then we also need sodium bicarbonate.
Sodium bicarbonate. You go get that. All right.
Yeah. We also need sodium bicarbonate.
So it's 10% aqueous sodium bicarbonate. 10% sodium bicarbonate in water. It's a mild base. Yep.
Yes.
Mild base. Got it. Right.
So the first thing we are going to do is to dissolve the unknown mixture, okay, in 15 milliliter of ethyl acetate. That's the solvent.
Okay.
Yeah.
In the organic solvent.
Yeah.
So you're pouring it in the test tube, yeah?
Yeah.
Alright. 15 mils. You're smashing it up in the spatula?
Yeah.
Okay. Is it dissolving?
It is, yeah.
It is dissolving.
It should, yeah. Sometimes it does take time, but that has to dissolve.
Okay, it's dissolved. Good. Mostly.
Yeah. So.
Yeah.
Still. At this stage, still need to be patient.
Yep.
You need to dissolve all. Still from here.
Alright. Back in the test tube?
Yeah.
And get the rest.
Some leftover, the rest.
Get the remainder.
Yeah. Put that back.
Okay. And you're going to use your separatory funnel.
Put the funnel.
And in the previous experiments, you did this in the fume hood because it was methylene chloride.
Yes.
And this is not a toxic one.
That's not a toxic one.
Methyl acetate's a non-toxic organic solvent, so that helps. And we can work out in the on the bench.
Yeah.
Okay.
So now we are going to do 2 extraction. This time with 15 milliliter of sodium bicarbonate.
Okay. Of the mild base, bicarbonate.
Open that.
So that's 15 mils of NaHCO3 bicarbonate.
Yes.
NaHCO3.
Close that.
Okay, two layers.
Yeah.
There's your glass plug on top.
Yeah. Shake it, prepare it.
Yep.
Shake it, prepare it.
Yep.
Shake it, prepare it.
That's it.
Like that. And you wait.
And we wait.
Yeah.
And it looks like it's resolving into 2 layers, huh?
Yeah.
That's cool.
Set.
Very nice.
Yeah. I need a 2 of cream over LMR flask. I need to
Okay.
get them from the stock room.
Get some cork ring. Yeah.
Yeah.
Okay, so you got the cork plugs, the
Yeah.
little plugs for the Erlenmeyer flasks.
Yeah.
Alright. Got those from the stock room.
Yeah. And I need to label these 2.
Label them with the tape.
Yeah. You need a second one. One will be labeled bicarbonate.
Bicarbonate.
We put sodium. Label 1/125 first bicarbonate.
Bicarbonate, got
That's
it?
the
Yeah.
ones we are going to use now.
Yeah.
And then next one will be NaOH.
NaOH?
Yeah.
Okay. Sodium hydroxide.
Sodium hydroxide. That's for later.
Yep. Okay. So now you're going to do the first extraction?
What?
Cool.
Yes. Remember, we'll take off.
Aha!
Always.
Don't make that mistake.
Yeah.
That's a rookie mistake.
Yeah. So
Always take the top off.
we were talking about that last week. In this case, you still have 2 layers. An aqueous layer at the bottom and an organic layer at the top. But in our today experiment, the aqueous layer is the bottom layer and the organic layer is the top layer. The aqueous layer is the bottom layer because water has a higher density than ethyl acetate.
Yep.
Okay, so
Yeah, and they can look up the density if they want of ethyl acetate. It's like 0.7 something. It's a smaller number than 1. It's 0.7
0.9
something.
something.
Like that, yeah. And but methylene chloride would be on the bottom because it has a higher density. But we're not using that.
And you use my 125 milliliter aluminum flask.
All right.
And I extract.
Drain out the bottom.
Bottom layer.
Alright, drain in, you're close, you're close, you're close.
Yeah.
Almost there, almost there.
Stop.
Stop.
That's the first one.
So that's the bicarbonate, yeah. Okay.
And I will do the second extraction with 15 more milliliter of sodium bicarbonate.
So it's the same solvent, same bicarbonate again?
Same bicarbonate, yeah.
Okay,
you leave the organic layer here.
Yeah.
And you do a second extraction with the same amount of the sodium bicarbonate.
Okay, so it's a double extraction.
Yeah. That's that.
Okay. 2 layers. Shake, shake, shake.
Shaking.
Vent it.
Venting.
Shake, shake, shake.
Shaking.
Vent.
Venting.
Shake, shake,
Shaking.
shake.
Venting.
Yeah.
Like that. Wait for the 2 layers to fall. See them here.
Yep, 2 layers.
Yeah.
Good.
And as you were saying the last time, that's the case. Remember you asked about the case where the organic layer will be the top layer.
Yeah.
And we spoke that day about ethyl acetate.
Ethyl acetate, yeah.
And that's the case today.
Yep, that's the case. Yeah.
So we have the 2 layers, organic layer on the top, aqueous layer at the bottom.
Good.
We take our sodium bicarbonate
So and that's the one that already has stuff in it, right?
Yeah.
From before.
and we do a second extraction.
Second extraction. You take the top out? Yep.
I take the bottom layer.
Yeah.
Take the bottom layer because that's what you need.
You need the aqueous layer. Okay, stop.
Stop.
Good. Perfect extraction.
So, what we do now, we close that. Put that somewhere. We're going to come back to that layer.
Come back to that one later.
Yeah.
Got it. Okay, cool. Don't lose it.
We close that, yeah. Now, we get NaOH.
Now you use the sodium hydroxide,
I'm going to
NaOH.
use sodium hydroxide. I'm going to make a small modification here. The Stockholm level of 5% sodium hydroxide,
Yeah.
I don't think it's correct because we went with 10%.
Yep.
I think we do need 10% sodium hydroxide, which I can get from the wood.
Okay. So
But address is 5%.
so this one's 5,
5%, yeah.
and you're gonna go get the 10.
10%, yeah.
10%. Okay, cool.
We're going to use the 10%
10%.
sodium hydroxide.
Get the big stuff.
Yeah.
The concentrated
Yeah.
sodium hydroxide.
And we do the same process.
Yep.
Take our beaker. 15 milliliter. We add that. Yeah. Close it.
All right.
Shake it.
You have to be careful. You don't want to get this on your hand.
Yeah.
It'll burn
That's
you.
why you need gloves.
Definitely gloves
Yeah. And
eye protection.
yeah.
Yeah,
Take
sodium
your time.
hydroxide will eat your eyes
Yeah.
and your hands.
Yes.
You'll eat everything.
Yeah.
Is it resolving?
Yeah.
Okay.
And as you can see here, you have your 2 layers. And what we need now, that's the bottom layer.
Same thing as before.
The same time
The
before.
bottom layer, yeah.
Because water has a higher density than ethyl acetate.
Okay.
So you open the top. You never forget to do that. And I do the first extraction.
Okay. And there's still a little bit of layer in there, I guess.
I will get that
Okay. Okay.
after.
All right. So you extracted the bottom sodium hydroxide (NaOH) layer.
Yeah.
Okay.
And now I will add 15 more milliliter.
Your second extraction.
Yeah. Make sure that you always close the container. Like that. Cover it. Shake it. Shake it. Very nice.
3 times.
Shake it. Very good. Here. Close
Good.
it and you wait.
Then you wait.
If you do not air vent, this one will just
Pop out.
pop out, yeah.
Probably break too, right?
Yeah.
And scare everybody in the lab.
Yeah. And you don't want that. You want
Yeah.
everybody to be well secured.
Sometimes if you look at the ceiling, there's little splotches where people had
Yes.
chemical explosions on the ceiling. Not that bad in this lab, but we've had a couple. Okay, so now it's 2 layers again.
Then we have 2 layers. You should fold, you open it up. And what you want, that's the bottom layer. Okay, now
Okay. Was that the second extraction or third? I don't remember. 2. The second
the
one, right?
second one, yeah.
Yeah. So, and you only do 2, right?
Yeah, I
Okay.
just did it.
So you're not gonna do the third one.
Yeah. Because I went with 15-15.
Yeah, 15 and
Instead of
15.
10-10,
Got
that
it.
will be
Yeah.
not enough.
Okay.
Close that.
Close your bottles.
Yeah. So there is a reason why we started the extraction with sodium bicarbonate. Because, let's say, the carboxylic acid were soluble in sodium bicarbonate, okay, and in our case here, we have an acid which is soluble in sodium bicarbonate. So that means that we are going to have a fair separation. Okay. So, but we also have the second extraction, which was with sodium hydroxide.
Yep.
Okay. And the phenol not soluble in let's say sodium hydroxide, this liquid here.
Yeah.
Use that to dissolve the phenol.
The phenol, yeah. So it seems like if you have a mixture of things with like two acidities, like you have a really acidic one and one that is not as acidic, the really acidic one will be extracted by bicarbonate.
Yeah.
But the one that's not as acidic, and phenols are less acidic.
Yeah.
Phenols are less acidic, and so then they'll come out with a sodium hydroxide.
Yeah.
And then it allows you to separate the two things. And
Yeah.
I think that, yeah, and they should know pKa, right? I think they, so an acid is a low pKa, it's like 4. Phenol is a high pKa, like 9 or something. So, yeah.
If you start with sodium hydroxide, you're not going to have any separation.
Yeah. Yeah.
Sodium hydroxide is a very strong base.
Yep.
Okay. So in the solution, you are going to have your phenol and your carboxylic acid.
Yep.
To prevent that, you start with sodium bicarbonate, as you said. That will kick out the acid. Okay. And if you have a phenol, you come with sodium hydroxide. Hydroxide, come with that, and you extract your phenol.
So it's a clever way to separate two different things of different acidities.
Yeah. The tricks here is absolutely to start with the extraction using sodium bicarbonate first.
Use the weak base first.
Yeah, yeah.
And then the strong
if you
base.
use the strong base, that means that you are going to screw on.
Yep. Okay. Okay, you're back with you got your paper trick to keep the fog out of your goggles.
Yes.
All right.
Here you have the organic layer, and if you have a neutral, if one of the unknown is a neutral, it will be in the organic layer. So what you do, put that in an extra aluminum flask.
Cool. Yeah, so because if it was acidic, it would have been removed by your other extractions.
And you label that.
But this one would be any leftover neutral molecules. Yeah, so you have, yep. Oh, you dropped it.
I will get that later.
Okay, so this is the neutral. It's your like leftover organic material, ethyl acetate.
Yeah. You don't know if you have a neutral yet.
You don't know.
I need to cover that.
Alright, so we'll cover the neutral with something. A little beaker.
Yeah.
Alright, so there's our neutral.
So,
okay.
We have performed 2 extractions.
Yeah.
Okay, the first one with sodium bicarbonate. That's to separate the acid, and the second one with sodium hydroxide. That's to isolate the phenol.
Phenol, yeah.
Yeah. So I will need to get some ice.
Oops. Okay. Okay, so you got a couple things of ice, normal ice, not dry ice.
Yeah.
Okay.
Normal ice, yes. Let me see why within that. So first, we are going to see if we have an acid.
Okay.
Okay. So because what you have here in this solution is not an acid.
Yeah.
Okay, it's an ion, and basically phenolate ion.
Phenolate or carboxylate?
Carboxylate ion.
Yeah.
Carboxylate ion.
Yeah, because this is the first extraction.
It's with carboxylic acid.
Yeah, the mild base should have removed carboxylic acid, but it's
acid, yes.
technically called a carboxylate right now.
Yeah, that's a carboxylate you have here.
Yeah.
I can draw that on the board.
Yep.
Okay, minus here and plus. That's what you have, eh?
Yeah, right, carboxylate underneath it.
Mm-hmm. Yeah.
Yeah.
That's
Yes.
a carboxylate.
It looks like a carboxylic acid, except
Because,
no OH.
Yeah.
It's
But-
a O minus and A plus.
Yeah, we have what is called aromatic carboxylic acid.
Yeah.
That means that the carboxylic acid group is attached to an aromatic ring.
Yep.
Okay, so that's what we have. Now, when you add minus, you add HCl. Okay, this is an acid-base reaction. Okay, so what will happen when you add hydrochloric acid? Now we come and grab that, and this one will go here.
Yep.
And then you are going to have your carboxylic acid. Let me draw that correctly. We put that at the bottom.
Carboxylic acid.
Plus Cl minus. And this one, because of sodium ion, that will be neutralized by Na plus.
And then the name of that carboxylic acid is also called benzoic
That's
acid.
benzoic acid.
Benzoic acid. B-E-N-Z-O-I-C acid.
Yeah.
Benzoic acid. Sweet. Yeah, cool.
We are going to add hydrochloric acid,
It's a 6 molar, yeah?
6 molar
So it's,
hydrochloric acid.
yeah,
You never pipette out of the container.
yeah.
What you do, you open, add to the beaker, and you close it.
Yeah. You don't want to contaminate it with your pipette stuff.
And then you add that. See?
All right. And of course it's bubbling because it's that's an acid-base reaction of
Yeah, yeah.
HCl and bicarbonate. It's like baking soda and vinegar almost, but not vinegar.
Yeah.
Put that in ice so it doesn't go too crazy.
Yeah. As you see here, you have your precipitate.
Whoa, what's that?
Carboxylic acid.
That looks like a solid. Yeah, I would probably guess that's a carboxylic acid. Yeah.
Yes, you have a precipitate.
Maybe it's the one we just saw. I don't know.
Yeah. Okay, you have that.
Benzoic acid, maybe. Yeah.
Here we show benzoic acid.
Yeah.
We spoke about benzoic acid here,
Yeah.
but we should be aware that we are not sure that the unknown we have, the unknown carboxylic acid we have, is benzoic acid.
Specifically, because
Yeah.
there's a million carboxylic acids.
Yes.
Okay.
So now, the next step will be a vacuum filtration.
Vacuum filtration.
So, first thing you do, if the vacuum is working, this vacuum is not working well, this vacuum is working very well. Let's check. So we need what's called a filtration flask, which we have here. We also need a clamp to secure the filtration flask.
Cool. Actually, there's a good one.
A very good one.
That'll hold it nicely.
Yeah, that's here. And that's to avoid technical mistakes. Put your filtration flask down. The hose. That's here. We need the neoprene adapter.
Neoprene adapter, the little rubber neoprene thing, yeah.
Put that
Not
on the
rubber,
top.
but
You
plastic.
need the Buchner funnel.
Buchner or Buchner.
Call that Buchner funnel.
It's a German.
Yeah. You know that.
I know that. Even I know that.
Yeah. Buchner funnel.
Which is for vacuum filtration.
Yes. Because of this, that, we call that
Umlaut.
umlaut, yeah.
German thing.
Yeah.
Umlaut. Buchner.
Buchner funnel.
Buchner. Not Buchner.
Yeah. So, we put that here.
Alright.
We need some filter paper.
You got some filter paper coming out?
Well, I have a bunch of them
Okay.
in my pocket. Put that here. This
You
one.
got a filter paper in there.
Yeah. Send this one back.
Alright, so now we're going to filter that solid, right?
Yeah.
So we're under vacuum and we're pulling it through, and yeah, it's a nice white solid.
Yeah, but we need some water. I'm going to get some water. That's just to get the rest.
So now you're pouring water into the flask and you're transferring it over. So you're trying to not lose any material.
Yeah.
You'll probably lose a little bit, that's okay. Couple washes.
Yeah.
Alright. Great. Alright, we'll wait a couple minutes while it's drying it.
Yeah.
It's drying it actually because it's sucking water through, all the water through. And this is going to get a little more dry. It's a nice white solid that we've isolated. Looks very clean.
It looks clean, yeah.
Okay.
I think this is okay.
Yeah.
Oh, it's good.
It looks good. You pushed it down with the spatula a little bit and
Yeah. I'm going to stop the vacuum.
turn off the vacuum.
And we are going to test the weight.
Take the weight.
Of the carboxylic acid.
You zeroed it, yeah?
Yeah, I did.
What do we got?
3.8 gram.
3.8 or 3.79 grams. We'll say 3.8. 3.8.
3.8 gram.
Yeah.
Of crude carboxylic acid.
Of crude carboxylic acid, because it's not. It's probably pretty pure, but not
If you want
extremely.
the pure ones, you need to recrystallize that.
Yeah. Yeah.
That's a crude
Yeah.
carboxylic acid.
So to really purify it, you would recrystallize
You
it.
need to recrystallize.
Yeah. But that's a nice isolation still. Okay.
Yeah.
Good.
So now.
So now we're going to deal with the phenol.
No, because we still have.
I know.
Eh? We need first perform the separation and isolation of crude carboxylic acid. Okay. Using sodium bicarbonate, and after that we add hydrochloric acid, okay, to the carbonate ion you see here on the board.
So the carboxylate.
Carboxylate.
Yeah.
Carboxylate you are seeing here on the board. We add hydrochloric acid, we did protonate, the ion, and we have here on the board is benzoic acid, but in the reality we don't know if the unknown we have is benzoic acid.
It could be any other solid carboxylic acid. But that's a good possibility.
Yeah.
Okay.
Now we are going to perform isolation of the phenol. Okay, so
Phenol.
we are going to use.
Yeah. So you're using your sodium hydroxide solution that you extracted before, and you're going to react it with acid, yeah?
Yeah.
Okay. Gonna get some fresh ice?
Yeah. We have a precipitate. That will mean that we have a phenol.
So if you observe a precipitate, then it might be phenol.
It might be a phenol, yes.
What do we got? Something's going on.
And you see here,
Yeah.
we have a precipitate.
Yes, it looks like we have a precipitate. Oh, maybe we have some phenol.
Yeah.
Okay.
That means that we have a phenol.
Yeah.
We have a phenol and a carboxylic acid.
So it looks like those are the two unknowns. Maybe a phenol and a carboxylic acid.
Now, next step, we are going to perform the second vacuum filtration. Okay. That I use the same Vishnu funnel.
Alright, so
And the paper.
paper on the
The
back.
vacuum is working very well, as you can see. That. Over here.
Yeah, it looks like you got some stuff, some solid.
Yeah.
So cool. So there's your
Good.
solid. You're letting it dry down a bit, and
Yeah.
maybe let it sit a while. Yeah.
Yeah.
Cool.
So here we did protonate carboxylate ion, and now I will write the phenol on the board. So what we have is basically that. Minus charge. And a plus. That's what we have. That's the phenolate ion.
What's this thing?
I put a
Oh.
a comma. So yeah.
Oh yeah. Okay.
I just put a comma here. So that.
Yeah.
Yeah. I will write here phenolate ion.
Phenolate. Phenolate.
Okay. That's what we have here.
Yeah.
Now you add hydrochloric acid. That's basically the same process. This one come, grab hydrogen, and this one goes back here. And what you have, I will write that here. And we have OH. Okay, and plus Cl minus. Cl minus here.
Yeah. No. What's the name of that molecule? What's the name of that one?
That's a phenol. Eh?
Oh yeah.
Yeah,
You want to draw it?
phenol,
Right
yeah.
that? Yeah.
That's a phenol.
That's phenol. Yeah.
Yeah.
Yeah. So you went from phenolate,
You did.
which is the anion, and then the final product is phenol, and that's the white solid, I think,
Yeah.
that you isolated.
Good.
Like before, you had carboxylate in it, then it went to the carboxylic acid.
Carboxylate, you react with hydrochloric acid, you have the carboxylic acid.
Yeah.
The phenolate, you react that with hydrochloric acid, you have phenol.
They make phenol. Cool. All right.
So,
Makes sense.
but in both cases, you are not sure that in this case, that benzoic acid, the carboxylic acid we have as unknown, and in this case, we are not sure that hydroxy benzene, because that's also the name of that,
Yeah.
is the phenol we have.
So you'd need some other analytical method, like
Yeah.
they don't know all the methods.
So now, knew that we had organic layer, okay, in this small aluminum flask.
The neutral, that was the
That
original
was,
ethyl acetate. Yeah. Yeah.
Which is
Original organic layer.
yeah.
Yeah.
But as you know, we just have two unknown, a mixture of two compounds. Okay? It's proof we have first a carboxylic acid and then a phenol,
Yeah.
which means that we do not have any neutron.
So 2 minus 2 is 0.
2 minus 2 is 0. So this one, I'm going to pour that into the organic waste boron.
So we assume it's nothing. Yeah, that makes sense.
We are 100% sure that we don't have a neutron. That's why we need to get rid of that. Here, you need to use a funnel, put like that, and you pour into the organic waste boron.
All right.
Okay? And then you close it again.
Okay.
So for a couple minutes, we did dry, okay, the phenol, and as you can see now, it's dry,
Nice white solid.
nice
yeah.
white solid. I can stop the vacuum, stop first. Once you stop the vacuum, you can pull that.
Yep.
Now, if the vacuum is still on and you want to take that out, what you need to do is to pull that, and then you can take it out.
Okay.
Okay. So we go to the room. We use the same process, and I bring that to 0. that, and then let's me rest here. So if you have here, it's just
looks like 0.07 grams, which is 70 milligrams.
70 milligrams of phenol.
Yeah. 70 milligrams of phenol.
But I remind you that what you have here, okay, is a crude phenol.
Crude. Yeah. Yeah, to purify it, you would probably...
To purify that, you need to recrystallize.
Okay.
And if it's the case, you need to figure out the solvent to recrystallize that.
Yep.
Now, to know the name of a unknown, okay, you do need to check the melting point at the 234 organic chemistry level. So we go with a melting point. If you go to OChem 2, organic chemistry 2, so we are going to check the NMA. Okay, but we are not doing that, so no NMA in OChem 1.
So yeah, they don't learn NMR until organic 2. NMR tells you the chemical structure.
Yeah.
So they have that to look forward to. So if they take organic 2 lecture in lab, they'll learn about NMR, which is an amazing, cool technique. But for today, you have melting point, yeah?
Yeah.
Okay.
But okay, you cannot take any melting point today.
Yeah.
You want me to start again?
No, that's fine.
You cannot take any melting point today because these two compounds are still wet. Okay, to have a correct melting point, you need to have a compound which is completely dry. That's not the case of either of these two unknown. Okay, that means that you cannot take any melting point today. To take a melting point, an accurate melting point, we need to do that next week, which we are not going to do.
Okay.
I will tell you the unknown, the name of unknown you had. Our carboxylic acid was 2-chlorobenzoic acid.
2-chlorobenzoic acid, all right. Cool.
And our phenol is 4-tert-butylphenol.
4-tert-butylphenol. 4-tert-butylphenol. Okay, cool.
Okay, so I need actually to write that on the board. Okay, that's our carboxylic acid, 2-chlorobenzoic acid.
2-chlorobenzoic acid. 2-chlorobenzoic acid. All right.
Carboxylic acid.
Yep.
That's position 1, position 2.
Position 2. All right.
1, 2.
All right.
I think that we do a nomenclature with you during the lecture. So now, that's the phenol, position 1.
Yep.
1, 2, 3, 4. Okay, 4. Phenol.
4-tert-butylphenol. Cool. Okay.
That's the phenol we have.
Yeah. Excellent. So we know both chemical structures, and as Organic 1 students, they don't really have the methods yet to figure out these structures, but they learn that later in Organic 2, or melting point would work too. So if they had a good melting point, that would also confirm the structure, I guess. Yeah.
Yes.
But yeah, great.
So what you have to keep in mind in this experiment, so if you have your unknown as you had at the beginning of the experiment, the first thing to do is to dissolve unknown in an organic solvent. Organic solvent we did use today to dissolve the unknown mixture was called ethyl acetate.
Draw that too. I think I'm not sure if they totally know that.
Yeah.
Ethyl acetate. This is an ester containing solvent.
I will call that ethyl acetate.
Yeah.
I think that once you do a nomenclature with Dr. Anderson or Dr. Kuhn, this one is also called ethyl ethanoate.
Ethanoate, yeah. Yeah, they don't learn that till Organic 2.
Okay.
But that's fine.
That's just information of ethyl.
Yeah, but it's a common solvent.
Yeah.
Ethyl ethanoate is one other name, yeah.
But if you go to the industry, most of the time people even do not know this name. If you go to order, they don't know that.
It is called ethyl acetate.
Yeah.
Cool.
So that's the solvent we use to dissolve the unknown mixture. Okay. What you should know about that solvent, it has a density lower than the density of water. That's why the organic solvent was the top layer. You only have to check the density to know what layer is the top layer and what layer is the bottom layer. So you should also be aware that we started the first extraction with sodium bicarbonate. Sodium bicarbonate, we started with aqueous. I will put that aqueous. Aqueous sodium bicarbonate. That was for the isolation, okay, of the carboxylic acid. If you start with NOH, aqueous NOH, you're not going to do any separation of the carboxylic acid and the phenol.
So you would just get a mixture of both of those.
Both of them, and you won't be able to perform any separation.
And that's like what you started with. It's like you'd be wasting your time.
Yeah.
So by doing this, it was a clever approach because the weak base isolated the carboxylic acid,
Yeah.
and the strong base isolated the weaker acid,
Yes.
which was the phenol. The
Yeah.
phenol is a weaker acid.
So, what Dr. Anderson is saying now is also very important to know. To avoid any confusion, I will remind you something. usually in chemistry, you speak about acid when the pH, okay, is lower than 7. Okay, because pH equals 7, that's neutral. But we, in organic chemistry, we consider the phenol as an acid.
So a weak acid. A weak acid.
Phenol as a weak acid. Okay, that's why. Because, as you know, in the reality, the pH of phenol is higher than 7.
So I would, let me see the chalk real quick. I would, what I would remind the students too, the pKa is determines the acidity. The pKa is like 9.
Yeah.
So the pKa of a phenol is 9. So if you need the pH to be greater than 9 to extract it, right?
Yeah.
And the pH of sodium hydroxide is like 14. So
Yeah,
that's why that works. Well, but for a carboxylic acid like benzoic acid or something, the pKa is much more acidic. So the pKa measures acidity, right?
Yeah.
And so it's around 4. And that bicarbonate can easily remove that proton. And that's why bicarbonate is really good at isolating the carboxylic acid. Whereas you need the super strong base to remove the proton in phenol. And that's how you extracted that.
Yeah.
So.
You know what? pKa, as Dr. Anderson did mention, the pKa is also important to know. In the rules, a compound, if you have two compounds, for example, and you want to know which one is, let's say, acid or basic. So, the compound with a higher pKa, okay, will be more basic, and the compound with a lower pKa will be more acidic.
Yeah. Cool. All right.
Yeah.